So, good evening to all. We will start in 10 minutes. We will wait for students to join. Then we will start. Okay.
Good evening, sir.
Okay, good evening all. So we will start now. So as usual, we will go with the revision of last week lectures, and then we will do some question answers based on the last week lectures. Okay, so let's start with the first lecture of last week. That was analysis of collection system, part one. Okay. So there are two types of collection system. We had read about the uh, before that we had read about the how to collect that waste, and after that collection at some curb side or street side, we have to collect that waste from that point, and we have to dump it at some uh, maybe landfill place, or the place at which you are going to segregate that waste, and you are going to modify that waste to to make some fuel or something like that. Okay, so there are two types of. Are you able to see the screen?
Yes, sir.
Okay, so there are two types of collection system basically. One is hall collection system, and one is stationary collection system. Okay, so in hall type of collection system, that is like you are collecting the waste from one point, or you are collecting the dustbin from one point, you are emptying it at hall site, and then you are again putting that dustbin at the hall side. Okay, so there are four units operations in this hall collection systems. First is pickup, then second is haul, at site, and off route. Okay, so coming to the hall container system, there are two modes. Okay, in that hall container system, one is conventional mode, in which what we are going to do, we have a pickup loaded container. We will pick up the container from first location, and we will haul it to the transfer station or maybe disposal site. Okay, or it can be MRF, like material recovery facility. Okay, so we are going to haul it till that point, that stationary point. Okay, we are going to empty it. Uh, 1 minute. Okay. So we are picking the container from this point. Okay, and then we are hauling it till the transfer station, MRF or disposal site, and then we are emptying it at that point. And again we are going back to that container location, and we are putting back the deposit, putting back the empty container. Okay, then from that site we are going to the second site, we are putting up the second container, and so on. Okay, then we will go to third site, and we will go to fourth site, and after 4 or 5 pickups, okay, uh, one truck had to do at least 4 to 5 pickups per day to provide the economy to the process. Okay, otherwise the process will not be economical if our truck is not doing 4 or 5 pickups in one day. Okay, then coming to the second type, one we had talked about conventional mode, then second one is exchange container mode. So in the exchange container mode, what we are doing, we are already going with an empty container at the site. Okay, we are going with an empty container to the container location. We are putting the empty container at the first location. Okay, and then we are picking up the uh,
Filled container.
filled container, and we are emptying it at the disposal site, and that empty container we are going to the second site, and we are going to put it at there. Okay, in this type of exchange container mode, what are the advantage? You don't have to um, your
Travel
distance of traveling will become lower as
time.
compared to your conventional mode, because you are already have a empty container, so you are putting it back at the site, and you are picking up the filled container from that side. Okay, so there are two types of mode in hall container system. One is conventional, and then one is exchange container mode. Then there are some calculations regarding the timing to complete that pickup in hall container systems. Okay, so we have to calculate that to provide to calculate the whole economy of the process. Okay, or you have to provide the minimum you have to calculate the entire duration of that hauled container system to provide minimum number of pickups for a single truck. Okay, you have to provide 4 pickups for a truck, or you have to provide 5 or 6 pickups for a truck. After after you are getting the economy of that whole process, then only you will be able to provide the number of pickups, minimum number of pickups for a single truck. Okay, so one is pickup. So this is denoted as PSCS, is referred to the time spent in picking up the loaded container from the site and redeposition of the container after it has been emptied. Okay, so there are two terms in this. One is PC and then one is UC, and driving to the next container after an empty container has been deposited. Okay, so what is the pickup? So this time when you are picking up the container, and the time when you are redepositing the container, empty container to the site, and the time between the two sites. Okay, from one haul container site to another haul container site. Okay, so that is known as pickup, PSCS. It is denoted as PSCS. We are talking about conventional mode. Okay, and then coming to the haul. Okay, so that is known as SCS. So what is haul? The time of traveling between from haul container site to your disposal site, and back from disposal site to that haul container site. Okay, so these two, the total of these two time will be known as the haul time. Okay, so that is denoted as SCS, the time required to reach the location where the waste will be emptied, starting when the container has been loaded on the truck and continuing through unloading until the truck arrives at the location where the empty container is to be redeposited. But it is not including the actual pickup timing and the timing to empty that container. We are only taking the timing of travel between the 2 points, haul container side and that disposal side. Okay, then coming to the third time period, that is at site. Okay, so at site time period includes the time which you are going to take to empty that container at the disposal or landfill or MRF site, or transfer, or we can say transfer station, at whatever the point you are going to empty that whole container. The time taken to empty that whole container, okay, that is known as at site time. Okay, so we had talked about four factors during this. There were 4 unit operation. One was pickup, then second was haul, third was at site, and now we will go to off route. Okay, so off route time is basically considered as a
Sir, sir, slides not moving.
slides not moving. Okay, let me see. Now it is moving.
No, sir, not visible. Now it's visible and it's moving, I guess. Yeah, it's moving
Okay,
now.
okay, okay. So coming to the fourth point, that is off route. So before that we had talked about the pickup operation, then haul operation, and at site operation. Now we are coming to the off route. So this is basically defined as the all time spent on all non-productive activities. Okay, non-productive activities like it spends time to check in for the workers, or meeting, or breaks, or coffee breaks, or time lost due to some unavoidable congestions. These are necessary times. Okay, and then there are some unnecessary times also, like time spent in personal errands or extended coffee breaks. Like we have given a coffee break to the workers for 10 or 15 minutes, but they are taking more than usual time for that coffee break. Okay, so that is known as off time. So the total time to complete that operation, okay, for that whole hall container system will be like the total of your pickup, haul, off route, and your at site time. Okay, so that will be the total time which is going to take, which you are going to take to dispose of the waste from one side, from haul side to the disposal side. Okay, so then this, in this haul container system, the time per trip will be considered as PSCS, which is basically haul container time. S, which is which was so we had talked about pickup time, we are talking about at site, and we are talking about off route. So that is PSCS plus S plus H. So that is going to be the total time per trip. The time required for a trip is the sum of pickup time, the on-site time, and the haul time. We are not considering the off-site time in the time per trip, because we are talking about per trip. But that off-site time is beyond that per trip time, because after every trip you are going to take that break as a off-site time. So the pickup time per trip may be expressed as follows: PSCS equal to PC plus UC plus DVC. PC equal to time required to pick up the loaded container, UC equal to time required to pick up empty container, and DVC is time required to drive container between container location. So for time per trip we had talked about PSCS plus S plus H, and in this PSCS we have three different things: PC plus UC plus DVC. Okay, then coming to the next one, the pickup and at site time are relatively constant, but haul time depends on haul speed and distance. So that is a that is a hyperbola function. Okay, for calculating these, we can the haul time may be expressed as a function of the distance travel, that is H equal to A plus BX. So A equal to empirical haul time constant. Okay, that will be constant. That time will include, like, you are picking up the container, the time taken for picking up the container and putting it back. Okay, so that time is going to be constant, and that B equal to empirical haul time constant, and X equal to average round trip haul distance. Okay, so as the haul distance is going to get increased, okay, so your BX term is going to get increased, because your imperial haul time constant is same. Okay, H per meter, hour per meter, but your meter per trip is going to change according to your locations, between according to the distance between the haul site and the container disposal site. Okay, so that is a hyperbola function. We can see how as your time, as your trip distance is getting increased, your haul speed is getting increased. Okay, then coming to the number of trips, the number of trips can be defined in a per day, how much number of trips you can do for a single truck. Okay, so that will be as H into 1 minus W equal minus T1 plus T2 divided by TSCS. Okay, so this ND term is number of trips per day. Okay, so how you are going to calculate that? First of all, we need length of work day. Okay, hours. Generally, it is 8 hours per day. Okay, then off route factor. We consider off route factor as 15% of the total time generally. Then time to drive between dispatch station to first container location to be serviced for the day. Okay, because in the first haul container side, you have to drive your truck from garage or dispatch station to the first container location. Then T2 is time to drive between last container location to be serviced for the day to the dispatch station or garage. And then TSCS we had already calculated, that is pickup time per trip. Okay, that includes your haul time, your pickup time, and time on site. Okay, so that we can calculate. Then there are some numericals, we will talk about them later. And the analysis of all container system, we will see some numerical based on these all container systems also. Then coming to the next point, next module. Okay, so we had talked about the hall container type system. Now we will talk about the stationary collection system. Okay, so there we had already talked about two types of collection system. One was hall container system, then second one is stationary collection system. So we had talked about hall container system. Now in stationary collection system, what we will do, we will pick up the empty container. So in the stationary collection system, what will be the procedure? So the procedure will be like this. Beginning of daily route, we will go to one side. We will collect the waste from that stationary point. We will empty the container at the place itself inside the truck. Then we will drive to the next pickup location. Okay, from first pickup location we had collected the waste. Then we are going to the second pickup location. We had collected the waste from that side. Then third and so on. Okay, so the collection point number of collection points for a single trip can vary according to the volume of the truck and the volume of the waste generated on that particular site or particular route. Okay, let's say the volume of the truck is fixed, like we have a truck of 6 meter cube volume. Okay, so from one collection site, we know that this collection site is providing the waste volume per day around 1 meter cube. Okay, and so on. Second or third site is also providing the 1 meter cube per 1 meter cube volume of waste per day. Okay, so according to that 6 meter cube volume, how much number of pickups we can provide in one go? Okay, so according to that, we can provide around 6 pickups in one go. Okay, we can pick up 1 meter cube waste from each site to fill that haul truck up to 6 meter cube, and then we will drive back to the transfer station or disposal site. Okay, so this type of system is known as stationary container system. In this type of system, we don't need to pick up the container from the site and empty it back to the disposal site. We will just empty the container at the site itself. So there are 4 unit operations in this type of container system also. One is pickup, then haul, at site and off route. So coming to the pickup, so it refers to the time spent in loading the vehicle, beginning with the stop to the load the first container and ending when the last container has been loaded. So pickup time is basically what we are coming to this point. Okay, so the time will start from this point. Okay, we have picked up the container, we had emptied it, then we are moving, then we are going again to the next side. We are taking the container, we are emptying it, and then we are going again to the third side and so on. So the total collection time is taken on this whole route is known as the piece SCS, which is pickup time. Okay, then coming to the next one, that is haul. Okay, so we had already talked about the haul time in haul container system. What we had talked from this side to the disposal side and coming back to this side is known as your haul time. So in this case, what we will talk about? We will talk about the time period taking from the last pickup point to the disposal side, and from that disposal side, the time taken for the next collection point. Okay, that will be your SCS. Okay, so you are driving the loaded collection vehicle to the location where contents of vehicles will be emptied, that is transfer station or MRF or disposal site, and from that disposal site you are again driving back your empty vehicle for to the collection point where you will start your next collection. Okay, so that is known as haul time. Then at site time, we had already talked about, it is similar to the haul container type system. At site time is nothing, the time taken between the loading and unloading of the time taken for the unloading of the waste at the disposal or MRF site. Okay, it also includes the time spent waiting to unload as well as the time spent unloading the waste from the container SC or collection vehicle. Then off-route time, this is generally considered as the non-productive activities and typically it is 15% of the total time period. Okay, so as we had already talked about, there are two different types of off-route times. One is necessary, then unnecessary. So
सर
necessary
इसमें
is,
आई हैव अ क्वेश्चन है.
yeah.
The whole time जो हमने देखा है सर, उसमें we are counting the time between collection site to disposal site, then disposal site to again new collection site. So that time,
Okay.
so whether that time will not cover this at site time also, sir, because if the truck is pick up from the collection site and went to disposal site, now if truck is queue to unload,
Okay.
so that
So
time is already being counted at the whole site, right?
no, 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 no. We are not talking in haul side time. We are not talking about the disposal time. Okay. We are not talking about the uh, we can say like
So we'll
unloading time
capture
of
the
that haul.
entry time only. We'll capture only here the entry side from collection to
Yes.
disposal side. Entry time we will
Entry
capture,
time.
and what time, whatever time that truck is spending in disposal side, that is not going to be counted in the haul side,
No, no.
right?
This is going to be counted in the at site time.
That's right. Okay,
Okay,
understood.
the time spent at the site where the system is unloaded. Okay, and it also include the time spent waiting to unload. So like we had once we had entered the we had entered the disposal site. After that, your at site time will get start. Okay, and once
Correct.
you are leaving that disposal site, once again your whole time will
Haul
start.
side will start. Correct.
Okay, and that off-route time is typically just like we generally consider it as 15% of the total time, and this includes the time spent in check-in, check-out, meeting or breaks, and time lost due to unavoidable congestion, time spent on equipment repairs or maintenance,
Yeah,
or
yeah.
some unnecessary factors like time spent in personal errands or extended coffee breaks. Okay, so just like we had calculated the total time in whole container type system, we will calculate the time in the stationary container system also. So mechanically loaded collection vehicle, we are talking about mechanically loaded collection vehicle in stationary container system. We are not talking about manually loaded collection vehicle. Okay, so in stationary container system the time will be TSCS, time per trip, will be the sum of your pickup time per trip, at site time per trip, A is empirical constant plus A plus BX, which is A is empirical constant like hour per trip, how much time you are taking per trip, and empirical B is also empirical constant. Then X equal to average round trip haul distance, that is miles per trip or we can say meters per trip, however we want to calculate it. So pickup time per trip will include your number of container emptied per day, containers per trip, that is CT, then UC, average unloading time per stationary container. Okay, so how much sites we are going to cover, like we are going to cover 6 or 8 or 10 sites in a day. So number of container emptied per day, then average unloading time per stationary container, NP minus 1 number of container pickup location per trip. So that we are considering NP minus 1, because why minus 1? Because for first container we are not going from one point to another point. We are talking about the disposal site or your garage site to that first pickup point. So that time we are not considering in the pickup time. Okay, so number of container pickup location per trip, and then DVC equal to time required to drive between container location. The pickup time depends upon the number of containers multiplied by the unit loading time plus the number of locations times the driving time between the locations. So number of trips per day will be ND equal to VD upon VR. So what is VD? Average daily quantity of waste collected, and V volume of collection vehicle, and R equal to compaction ratio, up to how much ratio we can compact that. We had already talked about in the second week lectures that we can compact the waste with the help of compaction trucks. like we can compact the waste up to 60 to 70% volume according to the compaction ratio. So if your trucks have a capacity of around 6 meter cube and you have a compaction ratio of around 50%, okay, so you can double up the number of collection points. Okay, like if we are taking 1 meter cube from one point, so for 6 meter, for filling up the 6 meter cube, you can go 12 collection points. Okay, because you have 50% compaction ratio also. So you can easily calculate the number of trips per day, how much trips you are going to require to collect the waste, then time required per day. So that will be T1 plus T2. So T1 is time to drive from dispatch station or garage or like for any location to the first container to be picked up on the first route of the day. Then T2 is time to drive from the approximate location to the last container pickup on the last route of the day to dispatch station. Okay, T1 plus T2 plus ND into TSCS. TSCS was hold time. Then 1 minus W. Okay, then manually loaded collection vehicle. We have some formula like N. Huh?
W क्या है सर?
W is your 1 minus W. If minute. Let me check. 1 minus W. We are talking about. A minute. There is some confusion. I will let you know. Once we go for the numericals, in that we will,
W is off route.
I think, off route time. Yeah. Okay. Then manually, we had talked about the uh, mechanically loaded collection vehicle for TSCS time. And for manually loaded collection vehicles, we have different formula for NP. NP equal to 60 PSCS N divided by TP. So 60 is like conversion factor from hours to minutes, and PSCS is pickup time per trip. NP is number of pickup locations per trip. Then N is number of collectors or laborers, whatever, how much labor is required for that collection. Because in manually loaded collection, you need laborers, like 5 or 6 laborers will be there who are going to empty that stationary container at that site to the collection truck. And then TP equal to pickup time per pickup locations. Then in the manually,
नंबर ऑफ कलेक्शन जो कलेक्टर्स हैं जो कलेक्ट कर रहे हैं,
yeah,
जैसे एक व्हीकल पे 2 लोग हैं, या मतलब वो वेरिएबल हो गया, जितना बढ़ते जाएगा वो
हाँ,
उतना मतलब वो टाइम मतलब उसका
that
कम
will
हो
be
जाएगा.
based on the volume of the waste which you have to collect. Okay.
Is there any
Because one person has a capacity.
formula? Is there any formula for deciding the number of collectors also? कि of which quantity of the waste collection we should deploy the number of people?
I think that is based on the volume actually. For you have to see how much a person can work. That is depend on that only. There is not a particular formula for that thing. How much number of labors you are going to require. That is generally on the understanding of the pupils. Okay,
Okay.
that will be based on that only. The pickup time per location depends on the time required to drive between containers location, the number of containers. So the TP equal to DVC plus K1CN plus K2 into PRH. So TP is average pickup time per pickup location, collector minute per location, how much time it is going to take at per location. And then DVC is average time spent driving between container location. Constant related to the pickup time per container. CN is average number of containers at each pickup location. Then K2 is constant related to the time required to collect waste from the backyard of a residence. And then PRH equal to rear of house pickup locations. So there is some problem statement. We will see it later. Then coming to the next one. Okay. So we had talked about the collection. Okay. We had talked about all container type system, or we had talked about stationary collection system. So now we will talk about transfer and transport. Okay. So what is the need and types of transfer stations? Okay. what is the need of those transfer station, and what are the different types of transfer stations. So there are some factors which needs uh, before the deciding of a transfer station, at which location you are providing a transfer station. We need to consider some factors, like a transfer station is a processing site where waste is deposited temporarily. Okay, as we had already as term describes itself, transfer. Okay, so we are taking the waste from the haul site or stationary container site, and we are putting it at some transfer station, and from that transfer station we are using even bigger trucks. Okay, if we were talking about 6 meter cube dense 6 meter cube volume trucks during that haul container collection system or stationary collection system, so from that transfer station we will use some even bigger trucks, like you can use 18-meter cube or 24-meter cube trucks to transfer that waste from that site to the landfill or the MRF, material recovery facility. Okay, so in transfer station, local waste collection vehicles deposit the waste cargo prior to their loading into larger vehicles. Okay, then these larger vehicles transport this waste to the treatment or recycling facilities or disposal sites. Then transfer and transport in solid waste management refers to the means, facilities and opportunities used to affect the transfer of waste from one location to another. It's like uh, you cannot provide a material recovery facility or disposal site inside a city. Okay, you have to make that site outside of the city, and the skirts of the cities, let's say if it is in the, like if it had a diameter of around 25 or 30 kilometers. Okay, so you cannot travel 25 or 30 kilometer in one go. Okay, from haul container site or stationary container site. Okay, so what you will do, you will provide some a transfer station between the city, like at a distance of around 15 kilometers. If we are talking about 30 kilometers, then we can provide a transfer station at around 7.5 or 10 kilometers. So what we will do, the haul container systems will collect the waste from those hauled container sites or stationary container sites, and they will transfer it to the transfer station, and from that transfer station the bigger trucks will take that waste and they will transport it to the disposal site outside the city. Okay, so to provide the better connectivity and better collection system, we use these transfer stations. So what are the need for transfer operation? Transfer operations are an integral part of all types of material recycling facilities. They are necessary when the whole distance.
सर जैसे दिल्ली में सर आई हैव अ क्वेश्चन हियर.
uh,
So like in Delhi, there are some divisions like area wise, and on those areas, or if club 2 3 mohalla or society we can say,
yeah,
then there is one station where material is being dumped for the
yes,
temporary basis, and by
yes.
evening they are processing that material and transporting it to the, I think, a bigger disposal site. So
Yes,
those are transfer station. Can we call them transfer station or?
yes, you can call them transfer station. From
Yes,
that transfer
according to
station,
you. And that mean all the dumping zones can be considered as a transfer stations, small
no, no,
dumping.
it's like in every mohalla you have seen some bigger sheds type
Yeah, yeah,
structure.
yeah. It's
Okay, that
understand.
is hauled site. Okay, that can be considered as haul site or stationary container sites because they contain some containers there. Okay, and from that curve side, they are picking them up, those hauled container or stationary containers. They are picking those waste and they are transferring it to the bigger sites. And at that bigger site, you can see some compactors there. Okay,
Okay.
if there are some compactors there at those sites, then you can consider them as a transfer station. Okay, because with the help of those compactors, what they are doing, they are compacting the waste. Okay, up to 50% or 60% by volume, and after that they are transferring it to the disposal sites or landfills, like Gazipur landfill. We in Delhi, if we talk about Delhi, there are three two to three landfill sites. One of them is Gazipur site. Okay,
Right, sir.
so that is your last stage, last disposal site. Before that, we have some transfer station, we have some hauled container system or stationary container system, and before those hauled or stationary container system, we have some curbside systems. Okay, curbside deposits where you are going to put your waste. From that curbside, they are picking it up, they are transferring it to some hauled container site. Then from that hauled container site, they are going for transfer station, and from transfer station, they are going for that Gazipur landfill site. Okay.
Okay.
So processing centers or disposal sites are in remote location. As we had already talked about, you cannot make some processing center or landfill site inside the city. Okay, you have to make them at some remote location away from the city. Okay, like and cannot be reached directly from highways. So generally, these are like 5 to 6 kilometers beyond from the city. Generally, they are like that. So like this. So these are the trucks which is going to collect the waste from the household itself. Okay, and these trucks are going to put them maybe directly to the transfer station, or they can put it at some hauled container site or stationary container site. They can empty these type of trucks. So small capacity. Okay, then these are the trucks which are which are used in haul container systems. Okay, so these are hauled containers which is going to pick the waste from that hauled site or stationary site and putting it to the transfer station. Okay, and then these are also the SCS types of haul container systems, and you can also use these transfer stations as a recycling center to make the process more sustainable. Okay, you can use those transfer stations to segregate the waste at the transfer stations itself if you have a bigger place for at that transfer station. And there are some types of transfer station. There are three types of transfer station depending on the method used to load the transport vehicles. One is direct load, then storage load, and third one is combined direct load and discharge load. So in the direct load, uh, one truck is coming. So you can understood from this type of system, one truck has come, haul container truck. It is directly putting all the municipal waste into some hopper, and this hopper is connected with the compactor. So this compactor is going to compact this waste up to 50 to 60%, and we had provided a container here. So this compactor is going to push all of the waste directly into that container. Again, some other truck will come, it is going to empty it, and this container is going to push that material inside that container, and this container is attached with some truck uh, on the other side, and that truck will transfer this waste to the disposal site or landfill site. Okay, so that is direct load transfer station. And then coming to the storage load transfer station. So in the type of storage load transfer station, so trucks are coming, they are emptying all the municipal waste at the site, and they are storing it. And that storage load transfer station, they can also segregate the waste in different categories. And from that storage, they are going to put them in the bigger trucks and to transport them to the disposal sites. Okay, so that is storage load type transfer station. And in the combined type station, we see both type of things. We can go for direct loading, or we can go for load transfer stations also. So some advantage and disadvantage of a transfer facilities are uh, a transfer facility can lower your collection cost. Like we had already talked about, if the distance between the hauled container site or stationary container site and disposal site is more than 15 or 20 kilometers, then you are going to need a transfer station between them. Okay, because what we had already talked about, in the hauled container system, the truck is going to pick up the waste from the hauled site, and it has, if the distance between the hauled container site and disposal site is around 30 kilometers, okay, so then it has to travel a distance of around 30 kilometers in one way and 30 kilometers back, okay, so the total distance will be around 60 kilometers. So while covering this 60 kilometer distance, what will happen, it is going to take more and more time during the transportation, okay, so the number of trips which is going to be completed in a day is going to be much lower as compared to if you are going to travel only 30-kilometer distance, okay, 15 kilometer from haul site to the transfer site, and 15 kilometer back from transfer site to the haul container site, okay, so you have to only travel 30 kilometers, so it can lower collection cost because you don't have to go every time around 60 kilometers, and with a much lower capacity truck, okay, so it can reduce fuel and maintenance cost for collection vehicles, increase flexibility in selecting disposal facilities, options to separate, recover recyclable or compostables at the transfer site itself, opportunity to shred or bale wastes before disposal. Okay, then disadvantages. There are some disadvantages also for transfer station, like difficulty with sitting and permitting, particularly in urban areas. Okay, in urban areas you can't make a transfer station in some like very highly density populated area, so you have to see the particular place to make a transfer station, okay, because it will create some odor and some health hazards problem in the surroundings also, so you have to choose the place very carefully for that transfer station. Construction and operation cost may make them undesirable for some communities, and if the uh, waste generation rate is not very much high in some community, so the operation cost might uh, contribute to the higher economy of the total process, okay, so the construction and operation cost may take them undesirable for some communities, okay, so these were the lectures from the last week, so now we will go for some uh, questions, okay, so I will share. Okay, so are you able to see the slides
Yes, sir.
and they are moving?
Yes, sir.
Okay. So, first question is, which of the following is not a unit operation of a collection system?
Because all which of the following is not unit operation? On site.
On site. Okay. So,
Is there on site is the off?
we had talked about some formulations, TCS, total collection time. So, that in that total collection time, we were not considering that on site time. Okay, and we are talking about collection system, so collection system will consist of your pickup time and haul time or off route time, whichever is going to take, so your on site time is not considered as a unit operation of a collection system. Then coming to the second one, in the waste collection systems, the haul container system includes.
The rest the whole container system is time required to
We are talking about haul time.
Sir, D.
Time spent at the location where the waste is unloaded. No, I don't think so. This is not all time. That is like on site. Time spent at the location where the waste is unloaded. That is considered as on site.
On site.
And then redeposition of the empty container. that is considered in the your pickup. Okay, there were four factors: pickup, on-site, off-site, and haul. Okay, and that
Wait,
ends.
time required to reach the location where the waste will be emptied.
Yes. So the haul will be the time required to reach the location where the waste will be emptied, and from that location going back to that haul site. So that is considered as haul time. Okay, and that actual picking up the up of the loaded container is also considered in the pickup time. Okay, so answer is time required to reach the location where the waste will be emptied. So next question. In the waste collection system, the off-route collection system includes.
Time spent on all
Time spent at
non-productive
the
activities.
sites.
Yeah, so redisposition of the empty container that comes under pickup time.
Check-in,
Time spent
check-out.
at site, it is on site. Okay, actual picking up of the loaded container, that is also come inside pickup time. So the off route is time spent on all non-productive activities,
Correct.
which
Tea
we
break,
consider like 15% of the total time.
check-in,
Okay,
check-out, and coffee break,
yes.
etc.
So after that, we will go with one numerical problem. So all of your next question is going to based on this numerical. A solid waste collector wishes to whatever. So we have some data. We have two different things. One is hauled container system, then stationary container system, and we had some factors like quantity of solid waste, container size, container utilization factor, container pickup time, haul time constant, at site time, overhead cost, and operational cost. So we had some data, and we had some location characteristics also. Average distance between container location is 0.16 kilometer, and constants for estimating driving time between container locations for both haul and stationary container systems are. We have some factors: A equal to 0.060 per hour per trip, and B equal to 0.042 hour per kilometer. Okay, so if you want, you can note down this data, because next 6 or 7 numerical problems we are going to based on these datas also. Okay, or we can show you data again and again, no problem. So we will go with the first question. So estimate the average pickup time for the hauled container system.
कैलकुलेटर लगेगा सर.
Okay, you can use calculator. This is the data. So this is your question. Estimate the average pickup time for the hauled container system, and this is the data. So you can try.
So for exam, we do need to remember the formulas then.
Okay. So yes, you need to remember some formulas, or it will depend on the faculty if they want to provide you some formulas, until unless otherwise you have to remember those formulas.
All container system है sir. Time, pickup time is time. PC we need to calculate on.
Yes, PC, average pickup time.
Responses filter. So,
So anyone got the answer?
Sir, I have a question.
Yeah.
Uh, for the hauled container system, what
Mhm.
is the how do you find out the container unloading time?
So we have given this container pickup time is 0.33 hour per trip, and what you are asking, I had not understand.
Container unloading time is given for stationary container system,
Okay.
but not given for hauled container system.
So we had given this at site time, no?
Yeah.
So at site time will include your container unloading time also at that stationary site at your transfer station. Because in hauled container system you have to pick up that container from that point and you have to unload it at the site. So we have
Yes.
given at site time, that is 0.053 hour per trip.
At site time includes container unloading also.
Yes.
sir, it's why the question that is estimate the average pickup time for the hauled container system.
Yes, so you have to calculate PCS. Okay, so let me
PCS.
show you.
What's the formula for the PCS, sir?
Yeah, I will come at that. So once first you can that is like extra determining the number of trips per week. You can determine that. So uh, for that you can calculate according to that weekly quantity of waste collected. Okay, whatever that quantity of waste we are collecting weekly, then average container size and
सर ये
container
ट्रिप तो
utilized.
ट्रिप इज द नेक्स्ट क्वेश्चन सर इससे पहले वाला जो है वो ट्रिप
Yeah, we are talking about fourth one only.
पिकअप टाइम सर
Yeah, we are talking about pickup time. Don't worry. Then we can calculate the number of trips per week according to this. Then for pickup time, the estimating the average pickup time for the hauled container system, which includes PSCS equal to
पीसी
PC
प्लस
plus UC
यूसी
plus
प्लस
DVC.
डीवीसी
Okay, so we have time required to pick up loaded container,
0.0113
hour per trip, time required to pick up empty container, and time required to drive between container location. So DVC we can write it at A plus BX. So what we need, we have given container pickup time 0.33 hour per trip. Okay. Then time
So here
required to
it is substituted as 0.033.
yeah, because 1 second. I think there is some mistakes. It has to be 0.033 hour per trip. Okay. 0.33 hour per trip container pickup time. So you will
So in that case, the choices I don't think you'll get any of. You have to check it.
we have to check this again. But the main thing is, if you are going to calculate that pickup time, so you have to use this formula PSCS equal to PC plus UC plus DVC, and DVC equal to A plus BX. So you can easily calculate your pickup time during that halt container system. So pickup time, what we are talking about? We are talking about picking up the container and unloading back again at the site. So it has to be around, I think it will not be 0.33 hour per trip, it will be 0.033 hour per trip, because 0.33 hour per trip, it's like 33 minutes. So you are not going to that much time to pick up that container from that site. It will take hardly 3 to 4 minutes only. Okay, so there is some mistakes in this container pickup time, that has to be 0.033 hour per trip. So you can easily calculate that according to that formula. So you remember what, when we were talking about pickup time, we had talked about the pickup of that hauled container, unloading it inside the picking up that hauled container. After that, the haul time will start. Okay, after picking up of container, the haul time will start. It will go to the landfill site or disposal site, and then it will come back to that location. Okay, then it will come back to that location, and it is going to put that container back. Okay, so that will be considered at your pickup time. Okay, so the answer is 0.133 hour per trip. Then coming to huh?
Okay, sir. That input is wrong there, right, sir?
Yes, input is wrong actually. That has to be 0.033, because it will not take 33 minutes in any case to pick up a whole container. It will take hardly 3 to 4 minutes only. Okay. Then coming to next question, estimate the time required per week.
Again, UC also it is the same, 0.033.
Yes, it will be same, 0.033.
Time trips per week formula.
Time required to pick up the container also is the same.
So next question is estimate the time required per week as a function of round trip haul distance for hauled container system. So we are talking about haul time. Okay, we have to calculate haul time.
It is time required per week.
Yes, as a function of the round trip haul distance for hauled container system.
So for that
So
we
the
need
formula
to
you are going to use is this.
time per trip, then multiply by 7.
As a function of round trip haul distance, because we don't know, we are not talking about haul distance here. We are not talking haul distance as a particular value. Okay, we will talk about haul distance as a x. Here x is this haul distance. So we have to calculate according to the round trip haul distance function. If you have that haul distance, you can calculate the entire time period for week.
So we have
So according to this, what we have,
whole time
we need
constants.
NW, we need PSCS. We have already calculated that PSCS. We need S. Okay, at time site we have S 0.053 hour per trip, and we have A value as 0.060 hour per trip. we have B value at 0.042 hour per kilometer, and X has to be X as a distance haul round trip, and uh, so you can calculate easily according to this formulation. Just you have to calculate NW and WI.
तो NW कैसे आएगा? How?
So NW, we had already calculated this, determines the number of trips per week. Okay, so that is weekly quantity of waste collected and average container size. We have an average container size of 6 meter cubes, and container utilization factor you have to keep in mind, that is only 0.67. Okay, so collecting the 230 meter cube of waste, how much trips you have to do in a week? Okay, so that will be 230 divided by 6 into 0.67. So the number of trips per week equal to is going to be 57 trips per week. Okay, so that is going to be your NW. And W we have here, we have W0, average distance between container locations equal to 0.16 kilometer, or we can consider it as 0.15.
So it will come 57 multiplied by 0.122 is 0.05 is dx. dx is सर bx आपने बताया था bx इक्वल टू
हाँ
bx आपने अभी बताया था सर लिस्ट.
हाँ, B, you have the value of B, all container time constant, B equal to 0.0414 hour per kilometer, and A equal to 0.022 hour per trip, and X is basically your haul distance. Okay, so you don't have to put that haul distance inside this formula. You have to calculate in the term of X only.
How to calculate x, sir?
That haul distance can vary according to your system. That has to be provided, because that will be the distance between the container side and your disposal side. Okay, hauled container, that distance is basically hauled container side, in between hauled container side and your disposal side. So if you can calculate the formula in terms of X, so you can easily calculate. So the it will come like 1.74 plus 0.12 into X. So if you have the value of this X, you can easily calculate the time required per week.
And here h is, sir, h.
H is all container size. We can calculate H as like we are talking about 57 trips per week.
Right,
okay.
Sir.
Okay, so 57 trips per week, and we have a working day of, if we can talk about 7 days per week. Okay, so we are going to divide 57 by 7. Okay, so it will come as 8. Okay, and when we consider about haul container system, we consider about
it will come in points actually.
That will be 57 trips per week. So 57 trips per week. So every truck with a capacity of around 6 meter cube has to do 8 trips per day. Okay, it's like you have to go 8 times in that haul distance. You have to go from one haul. You have to go at one haul container. You will pick up that haul container. Okay, you will dispose it off at disposal site. Then you will go again back to second haul container. Then third, fourth, fifth, sixth. So providing 57 trips per week, you have to make at least 8 trips per day. Okay, so that is H. How many trips you are going to do per day? That is your H. And why we are going with 1 minus W? Any idea? What was W?
Walls.
W was, what was W? W was our off site. Okay, that is unnecessary times which is going to take. Okay, so that we were considering it as 0.15. Okay, and why 1 minus 0.15? Because we are considering it as because for in one site for every because we are talking about 8 trips, 8 haul trips. Okay, so in that 8 haul trips, what we will see, sorry, W is basically your this what is this wait a minute, there is some confusion. Yeah, this is average distance between container location. So this is given as 0.16 or 0.15 kilometer. So when we are talking about this, so when we are talking about 8 trips, okay. So in 8 trips, how much time you have to go back and forth? Okay, we will take 1 minus according to that, because in last
But
trips
sir,
you don't.
I'm still not clear how W is calculated.
What calculated?
How
W
come
is
this
cal. Okay,
0.15 is coming?
okay. We will see it. Let me check. I am also a little bit confused about W. I think that 0.15 is like we had talked about that factor of 15% in that our offsite. When we were talking about offsite, we had talked a factor of 0.15 somewhere. That is considered as W, I think. Yeah, this is time required per day 1 minus W, and T1, T2, and where is this W?
Yeah, this is
Yeah,
of
off
the
route, typically 15%.
typically 50%.
Yeah,
Okay, that
this ref,
15% we have taken into consideration.
yes. Okay, that 15% we has considered as W, 1 minus 0.15. Okay, and that 8, you had understood the H, how we had calculated this H.
Here per day, sir. Trip per day.
Yeah, trips per day. Okay, so according to that formulation, we can calculate this uh, this equation for time required per week for a whole container system. Okay, so if we know the X value of X in this system, okay, so we can easily calculate the time required per week, because we don't have the X value, so we can not calculate this. Okay, so coming to next question, estimate the weekly operational cost as a function of round trip haul distance for the hauled container system. So now we have to calculate the operational cost for a functional round trip haul distance for the hauled container system in the terms of X, obviously, because we don't have the distance. When we were talking about data, this is data. So we have data in the
तो सर
terms
ये
of cost.
हमने जो अभी निकाला है ऑप्शन
हाँ.
ए जो हमारा आंसर आया है इसको हम
Yes.
कॉस्ट से मल्टीप्लाई कर देंगे तो ये आंसर आ जाएगा ना, बिकॉज ये वीक का पूरा जो हमने वो निकाला है
Yes.
जितना हमने टाइम लगाया है.
Yes. That will be your operational cost. Okay. And that operational cost plus your overhead cost. Okay. So we are talking about two different costs. One is overhead cost, that is rupees 28464 per week. And your operational cost is 1067 per hour of operation. Okay. And we had already calculated that estimated
टोटल
time
आवर्स.
required per week, total hours, okay, TW. So we can go with that. So
तो
operational
वी
cost will be,
सर एक और वन क्वेश्चन है, तो विल कन्वर्ट अवर टोटल टाइम स्पेंड इन द वीक्स इन आवर्स, so that is
yes,
already in hours actually. Multiply by 1067
no,
करेंगे तो आंसर नहीं आएगा. तो
no,
will we get the answer?
here you can see 1.74 plus 0.12x in the terms of day per week.
Day per week. Will okay.
Okay, we are talking about day per week, and in one day we consider around 8 hours.
8 hours.
Okay, 8 hours per day. So it will be like operational cost will be operational cost per hour into daily total cost of total hours of operation, that is 8 hours, and
8
then
hours.
time required per week. So we had already calculated that time required per week, TW, in terms of day per week. So we can calculate it operational cost as 14582.64 like this in the terms of X. And if we are going to sum up the operational cost and your
And
overhead cost, okay, so that is going to provide you the total cost for per week. Okay, so the total cost will be the sum of your operational cost and your overhead cost. And we had given you the overhead cost here at 28464 per week, and operational cost was rupees 1067 per hour of operation. And we have the number of operation per hour of operation. Okay. So you can easily calculate that according to this formulation. And now coming to next question.
sir,
Estimate.
sir, please go back to the next question. So overall, okay, operational and overhead will be adding up, so it will give us.
Yes.
Correct. ठीक है sir.
Because that has to be fixed. That overhead cost is fixed per week.
Yeah. Agree
Okay.
sir.
Operational cost will vary according to your distance. Because that will according to distance you are because this operational cost will conclude the charges of diesels. Okay, so the charges of diesel you are going to consume will depend on the X value, how much kilometer you are traveling all day long. Okay, so that will depend on that, but overhead cost will be fixed for your week or month, whenever whatever term you are talking about, that will be fixed. So the total cost will be operational plus overhead cost. Okay.
Correct sir.
So we had talked about in previous questions, we had talked about all container system. Now we will talk about stationary system. So the estimate the number of containers emptied per trip for the stationary system. So stationary container system, we were also talking about quantity of solid waste is similar, 230 meter per cube, 230 meter cube per week, and container size is 6 meter cube per location, and container utilization factor is 0.67.
Collection copied is 23. Number of
So we had already calculated that NW, that will be same for this also. Number of containers will be similar. that will be 57, I think. Or you can again calculate that.
Which
So your
formula will be
total,
applied here, sir?
huh?
Which formula we will apply here, sir?
This is simply mass balance. Like if you are talking about number of containers emptied per trip for the stationary system. So what we will talk about, we are talking about
Total quantity divided by
230 meter cube of waste. Okay.
correct divide.
And in
Okay,
every trip, you can carry, you have a truck of 6 meter cube.
correct, sir. Number of uh,
And we have a collection vehicle capacity. Here we have to consider this thing also. Collection vehicle capacity is 23 meter cube per trip. Okay. And one container size at stationary container system is 6 meter cube. And container utilization factor is 0.67. Okay. So
divided by
in one trip,
23.
what you are going to do, 23 divided by 6 into 0.67, I think. And collection vehicle compaction ratio is also there, 2. So your total volume will get increased from 23 meter cube to 2 times. Okay, so that will be 46 meter cube. You can fill up inside that container, and you have to divide it with the 6 into 0.67. Calculations.
230 divided by
No, 230 will not be considered here, I think. Because you have a vehicle capacity, na? You have to
hmm,
consider that vehicle capacity. You have a vehicle capacity of 23 meter cube per trip. Okay. And
and 6
you
is
have a
the
compaction ratio of 2. You can compact it double. It
multiplied
means
by
you
2.
can fill 23 into 2 times.
Correct, sir.
Okay, so you can fill that vehicle up to 46 meter cubes.
46 meter cubes
And every container has a size of 6 meter cube
with
and a
167 capacity.
and a utilization fraction of factor of around 0.67.
167, correct.
So that will be 46 divided by 6
6
into
multiplied by
0.67.
0.67. So, six multiplied by 6.
So that will be like this. You will get answer around 11.44.
11.4427.
Okay. So 11.44. In the waste utilization, you always have to consider the lower value. Okay. Because you cannot fill the container from that 46 meter cube, beyond that 46 meter cube.
Because
Okay.
we don't have the container.
So you have to fill, you can fill around 11 containers per trip. Okay. Either it is 11, if it has come 11.67, then also you have to consider only 11. You always have to go on the lower side. It's not like you have to round it off. So not get confused with that round off thing. So even if it is 11.67 or 11.89, then also you have to go for 11 containers only. Okay. So coming to next one, estimate the pickup time per container for the stationary container system.
तो कलेक्शन साइड डिपॉजिट साइड का टोटल करेंगे.
Yes. So we have this data. So what data we have? We have container unloading time around 0.05 hours per container, and that whole time constant is A equal to 0.022 hour per trip and B equal to 0.14 hour per kilometer, and at site time is this. So what was the pickup time? So when we were discussing about pickup time of stationary container system, we had talked about the time period taking to pick
From
up all containers. Okay, so we were talking about 11 containers in a row. Okay, in one trip we have to pick up 11 containers, and whatever the total time is going to get between that one first container to that 11 container, that is going to be your pickup time. Okay, that will also consider the time of the traveling between from one container to second container to third container to fourth container. That will also consider the traveling time also. You have to
correct.
consider that also in this case. So that will be your overall pickup time per container for the stationary container system. So for pickup time, we were having a formula. We have discussed about PSCS equal to CTUC plus NP minus 1 DVC, and DVC we can write it at A plus BX. So we have A, we have B, we have NP, we have U and C and CT. We have all things. We have
So
average distance between containers 0.16 kilometer. We have A for this stationary container system, and we have B for stationary container system. So we have X, we have A, we have B, and what will be the NP?
number of trips per day.
Yes. So it will be like this. So CT, that is your number of containers that you have to pick up in one time period. That will be 11. Then coming to UC, this is 0.050 that we have considered here. Container unloading time,
Unloading
that
time.
is 0.05 hours per container. Okay. Then other things we already have. NP 11 minus 1, then 0.060 minus plus 0.042 into 0.16. So the total pickup time per container for the stationary container system will be 1.22 hours per trip.
सर ये NP11 how we are considering 11 NP
Number of pickups.
since 11 container है तो pickups will be 11.
Yes. In one trip, you have to pick up 11 number of containers in one trip. So the overall trip timing will be 1.22 hour per trip. Okay.
And the value of BX,
B and X we have given. These are constant values.
B we
For
have X,
X we have given average distance between container location 0.16 kilometer.
okay,
That is 0.16. A we have, B we have, and
yeah,
X is
X,
0.16. Okay.
correct sir.
Then coming to next question, estimate the number of trips required per week. So this is simple, I think.
अभी हमने जो सॉल्व किया है सर
We were talking about a waste of 230 meter cube. Okay.
करेक्ट सर
In 1 week, we were generating 230 meter cube of waste, and in one trip, we are collecting 11
11
containers
per trip.
we were collecting. Okay. And every container has a volume of so number of containers, how we can calculate number of containers?
Number of units the capacity is 6 and utilization is 0.6.
Yes, 230 divided by 6 into 0.67, that utilization factor. Okay,
Correct, sir.
so number of containers will come to around 57, if I am right.
Right, sir.
Okay, so you just have to divide this 57 by 11, because
11.
in one trip you are collecting 11 number of containers. Okay, so you just have to do around
Five, five trips per week.
5 trips per week only. So which one is better according to you? All container system or stationary? Huh?
5 trips per a week is cost effective, sir.
Uh, According to our preliminary calculation, whatever we have done till now in previous questions, we were doing 57 trips in the whole container system. Okay, we have calculated number of trips as 57. Okay,
Correct, sir.
and in this case, we are talking only about 5 trips per week. We were doing 57 trips per week there, and we are doing only 5 trips per week here.
So it is cost
So
effective.
in that case, the
It's cheap.
stationary system will be cost effective if the factors are similar in both cases. But there depends on many other factors
Other
also, like
factors, sir.
in some cases you cannot apply your stationary compact stationary system, and in some cases you cannot apply whole container system. You have to choose wisely according to the geographical conditions. Okay, on that note you have to decide those things. Then coming to the last question, estimate the time required per week TW as a function of the round trip haul distance for the stationary container system. So previously we had calculated the time required per week for the hauled container system. Now we have to calculate it for the stationary container system. So we had used some formula in that hauled container system. So we are going to use again a formula for stationary container system. So in case of stationary container system, the formula will be TW equal to NW, which we had already calculated number of trips per week. PSCS, we have calculated the pickup time, okay, as 1.22 hours. We have calculated TW, and then S plus A plus BX divided by H into 1 minus W. So that formula we can use for estimating the time required per week, but we are not considering the distance between the last container side and your disposal side. That is considered as X. In haul container system, we were talking about one haul container to the disposal side. Okay. In this system, we are talking about distance between the last container and the disposal side. So that is going to be your X term. Okay.
Okay,
Any
sir.
doubt?
No, sir. ये एन डब्ल्यू सर एक मिनट सर, इसमें एन डब्ल्यू जो 5 आया है सर,
Yeah.
हमने जो पहले कैलकुलेट किया था,
That we had calculated here 5 trips per week.
अच्छा वो HCS में किया था. ओके, आई गॉट कंफ्यूज एक्चुअली.
57 we had calculated for hauled container
ऑल
system.
करेक्ट, एग्जैक्टली. और हियर वी गॉट 5.
Yes.
करेक्ट सर.
Okay, so if you have any questions.
सर ये फॉर्मूला एंड कैलकुलेटर्स आर गोइंग टू बी डिफिकल्ट थिंग.
Yeah, a little bit, but you have to learn them for your final calculations.
So how many marks it contributes, sir, this formula and calculation?
I think it will be around 15 to 20 marks, something like that, because there will be more theory which has to be come yet. Around 60-70% theoretical part will also be there, but you have to remember these formulas.
And how much time will be given for final exam, sir?
I think 3 hours.
Okay. So sir, these formulas, if we want to practice further, so we can further practice from the course material.
Yes, you can practice from the course material.
Okay.
Sir, examination will be objective, right?
It's similar, I guess.
Multiple choice question.
It will be both like it will be objective and it will be subjective also. So you have to write down the answers on that answer sheet. It will not be on computer. It will be on handwritten sheets. You have to give it offline.
Okay.
Okay, it's going to be like regular exams, sir.
Yeah, it will be going to be like regular exam, but there will be some objective questions also, and there will be some subjective questions also. Okay, so we will conclude this session. Okay, maybe I will not take the class next Sunday. Maybe it can happen on maybe Thursday or Saturday. They will inform you with the mail. I will inform them regarding the new timing. It can be, it will be either on Thursday or maybe Saturday, because on Sunday I will be traveling, so there will be no class on Sunday. Okay.
Okay, sir.
Okay. Okay. Thank you. Thank
Okay,
you
sir.
all.
Thank you, sir.